Hey guys! So in our last video we had a look at some of the different index laws used for solving algebraic equations. And for each of them we had a look at a brief example that sort of showed how they work or how they are derived. In this video we're going to have a look at a few examples of simplifying algebraic equations using these different index laws. And you'll see sometimes we'll need multiple index laws in order to simplify. So let's start out with a straightforward example. Let's say you're asked to simplify the following: x to the power of 4 times y to the power of 3. So in this case, you can see that none of our index laws actually fit. Despite the first one being similar in nature, the base of the equations are different, which means we actually can't do anything to combine the indices. So here there's actually no simplification, or it's in a simplest form already. So that's just something to look out for. You may come across that. You can only use the index law where the bases are the same. So another example, let's say we simplify the following: s to the negative 2 all raised to the power of 5. So here we're using our third index law because it's in the same form, and substituting in the components, we'll see we end up with s to the negative 2 times 5, which of course is s to the negative 10. So we can stop here if we like, or we can also use our fifth index law to get rid of the negative indice and represent this as 1 over s to the 10. Depending on the equation you're solving or the context of the equation, it may be better to leave your result in the form that we had initially, s to the negative 10, or it may be better to put it in the denominator of a fraction. So that sort of depends on context. But both are correct. Both are in simple forms. So next example, let's say you have 4a squared times 3a squared. What can we do here to simplify? Well, first let's have a look at the a's. Once again, we can use the first index law, and we're left with a to the power of 2 plus 2. And in this case, we can multiply the 3 and the 4 together outside the front of a, and we're left with 12. So simplifying the index of a, 12a to the power of 4 is what we're left with. So next, 3x to the power of 4 times 2x to the power of 3 divided by x squared. So here you can see that we're going to have to use a combination of at least the first and second index laws because we have a multiplication and a division. So let's start out by using the first index law on just the first two components. So 3 times 2 is 6. We're left with x to the power of 4 plus 3. And what we can do as well is write out the x squared on the denominator of our fraction instead of representing it all on the same line using the division symbol. And by solving the equation in the index, we're left with 6 to the power of 7 over x squared. So what we can do here is, just as if we're solving any fraction with the same term on the top and the bottom, we know we can cancel that value out. We can do the same with the components of our indices. So if we remove this 2, we also need to cancel out 2 x's from the numerator here, which leaves us with 7 minus 5, which equals 2, which you can see relates back to our second index law. So that leaves us with 6x to the power of 5, and nothing in the denominator because we've cancelled it out. So that's the answer of that one. The more examples you do, the quicker you'll become with your simplification, and these laws will become second nature to you. So the next one, a little bit more complicated once again. X to the power of 4 times 6x to the negative 3 divided by 2x squared. So how do we simplify this? Let's first address these first two terms. 6 times 1 will be 6 out the front. And we're left with x to the power of 4 plus negative 3 using our first index law. And what we can do here once again is in the denominator record our second component. 2x to the power of 2. So simplifying this, we're left with 6x, and 4 plus negative 3, 4 minus 3 is 1, so we're just left with 6x, and in the denominator, 2x squared. So once again, we can cross out an x from the bottom and an x from the top, and as well we can cross out 6 on 2 to represent it as 3 on 1, or just 3. So by doing so, we're left with just 3 on the top, and in the denominator, we're left with x. So that's our answer, or using the fifth index law, we can also represent this as 3x to the negative 1. So either way is fine once again. And let's have a look at our last example for this video. Let's say you have x to the negative 4, all raised to the power of 2, times 9x cubed divided by 6x squared. So how do we simplify this? First, we can simplify the first component using our third index law, which is going to become x to the negative 4 times 2, which is negative 8. And let's write out the rest of our components. And we can put the 6x squared in the denominator. Maybe it will make it easier for us. So simplifying the numerator by using our first index law will result in 9x negative 8 plus 3, which is negative 5. And in the denominator, we can leave our 6x squared. So here we can cancel out 9 over 6 for 3 on 2. But you can see, because we've got a negative number in the indice of the numerator, it makes it a little bit tricky to visualize how to cross out the different components. So what we could do here to make it a bit easier is rewrite this, take the 3 on 2 out of the equation, and rewrite this as 3 on 2 x to the negative 5 divided by x squared, which now we can apply our second index law, and we're left with 3 on 2 x to the negative 5 minus 2 x to the negative 7. And this is our answer, or we can use the fifth index law again if we like, and rewrite this as 3 over 2x to the 7. So once again, either of these last two would be fine, depending on the context of the simplification. So that's it for a few different examples. Hope you enjoyed. If you have any further questions that you'd like me to assist with, please leave in the comments below. And thanks. Have a great day. Bye.